Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So today I want to discuss about one of the important theorem in vector integration, that is Gauss Divergence Theorem. So here in this video we are going to know about what is the Gauss Divergence Theorem, what is the definition, what are the formula, and what is the statement. So what are the problems we can do by using this Gauss Divergence Theorem? We are going to see now. So let you know first what is the Gauss Divergence Theorem. So in this theorem, we are enabled to convert the surface integral of a vector function on a closed in surface integral to volume integral. So here we are getting the transformation from surface integral to volume integral. So that means if they given the problem surface integral, we can convert or we can simplify that problem to solve easily by using the volume integral also. For example, that problem is in volume integral. If it may be solvable simply by using the surface integral, we can use the surface integral formula also. How it is possible? So we can see now by using the statement. So this is the statement of the Gauss Divergence Theorem. So what is the statement of the Gauss Divergence Theorem? If V is volume bounded by a closed surfaces and if the vector function f bar is continuous and has continuous partial derivatives. So here f bar is continuous and has the continuous partial derivatives in V and on S, then that is double integral over S f bar dot n bar ds is equal to triple integral over V del dot f dv. So here n bar is the unit outward normal to the surfaces and here dv is dx dy dz. So already we discussed this formula, this one in the surface integral. What is the n cap is unit outward normal. What is the formula for that? This is all information already we discussed in the surface integral. So here that is the basic information you should have about the previous topics also to solve the problems. So those formulas we are going to use in the problems. Okay. So first here in this you should remember about the statement of the Gauss Divergence Theorem. Here that is double integral over S f bar dot n ds is equal to triple integral over V f del dot f dv. So here we are going to see how we can solve, what type of problems will be there by using the Gauss Divergence Theorem. See here, these are the problems on Gauss Divergence Theorem. Here two types of problems will be there. One type is using Gauss Divergence Theorem. So in this place, second model, they can give verify Gauss Divergence Theorem. So these two type of problems will be there. In this one here, using Gauss Divergence Theorem means only one part will be evaluated. So verify Gauss Divergence Theorem means you have to solve two parts. That is here this value LHS value and RHS value both you have to evaluate. If they are asking verify Gauss Divergence Theorem. So if they are asking to using Gauss Divergence Theorem, you can use any one to get the answer. So you can observe here in the question what they are asking, using Gauss Divergence Theorem for vector is given f bar is 4xzi minus y square j plus yzk over the cube bounded by x equal to 0 and x equal to 1, y equal to 0 and y equal to 1, z equal to 0 and z equal to 1. So here this is the cube they given the figure. So you can observe here this is the cube. So we are taking the cube all surfaces. So here we are going to calculate this value. Okay. So here using Gauss Divergence Theorem, F bar over cube is bounded by x equal to 0, x equal to 1, y equal to 0, y equal to 1 and z equal to 0, z equal to 1. So here we are using the Gauss Divergence Theorem means we are going to calculate integral over v del dot f dv, del dot f dv. So here if they are asking same one, if verify Gauss Divergence Theorem for the vector means then we have to do two LHS part and RHS part. So here observe, first we are going to write the given data, after then we are going to write the statement. So first given what they given f bar equal to 4xz I bar minus y square j bar plus yz k bar. This is the given vector and they given the cube is bounded by x equal to 0, x equal to 1, y equal to 0, y equal to 1 and z equal to 0, z equal to 1. This is the given data. So according to the Gauss Divergence Theorem statement, double integral over S f bar dot nds is equal to triple integral over v del dot f dv. So here we can calculate surface integral also to get the answer, or otherwise volume integral also, because these both are equal according to the Gauss Divergence Theorem. So here we are writing given 4xz into I bar minus y square j bar plus yz k bar. So here I am going to calculate del dot f. So what is the meaning of del dot f? So here first of all, what is the del you should know. So already we are having this information in the vector differentiation also and in the previous videos for the surface integral also we discussed. Anyway, just I am giving the outlines for this. Del equal to I dou by dou x plus j dou by dou y plus k dou by dou z. This is the del operator. So we are using this del operator for the dot product and cross product. So here we are going to calculate f bar, del dot f bar. So already we know the f bar. So del dot f bar means del is I dou by dou x plus j dou by dou y plus k dou by dou z. Dot f is 4xzi minus y square j plus yzk. So now I dot I is 1, j dot j is 1 like that. So first one is dou by dou x of 4xz, dou by dou x of 4xz. Next I dot I is 1, right? So next one is dou by dou y of minus y square, that is j dot j is 1. Next plus dou by dou z of yz, dou by dou z of yz k dot k is 1. So now we are doing dou by dou x, that means partial differentiation with respect to x for 4xz. So when you are doing with respect to x, 4 is the constant and z is the constant, x is 1. So we got 4z. Next plus here with respect to y we are doing here y square is there, that means this is minus 2y. So minus 2y second term. Third term we are doing with respect to z here. So y is the constant, z is 1. So plus y. So here 4z minus 2y plus y. So here minus 2y plus y is becomes minus y. So del dot f value is 4z minus y. So del dot f value is 4z minus y. So we calculated this value. Now we can integrate the function by using the. Now we are calculating this RHS part. So only we need one part, LHS or RHS, because they are asking using Gauss Divergence Theorem. So here RHS double integral over v del dot f dv, del dot f dv. In the statement only they given dv is nothing but dx dy dz, dx dy dz. So here already we calculated del dot f value, that is 4z minus y into dx dy dz. So already in the problem they given x values are x equal to 0 and x equal to 1, y equal to 0 and y equal to 1 and z equal to 0 and z equal to 1. Now here, so now based on this data, we are going to write this integral 0 to 1. Integral 0 to 1. So z limits are integral 0 to 1. Y limits are integral 0 to 1. X limits are integral 0 to 1. So here, three values are constant. That means x and y and z, all limits are constant. Means we can do first with respect to x also, with respect to y also, with respect to z also. So according to that, we can calculate. Here first we are doing with respect to x. That means double integral 0 to 1, here 0 to 1. With respect to x we are doing, that means 4z is the constant. Integral dx is x. Limits are 0 to 1. Minus y is the constant. Integral dx is x. Limits are 0 to 1. Into, so dy dz. So here integral 0 to 1, integral 0 to 1, 4z into 1 minus 0 minus y into 1 minus 0 into, so upper limit minus lower. So dy dz. So here integral 0 to 1, 4z upper limit minus lower limit. So 1 minus 0 minus y into upper limit minus lower limit. So 1 minus 0 dy dz. So here integral 0 to 1, 4z minus y dy dz. Now I am doing with respect to y first. So integral 0 to 1, 4z. So integral dy is y, limits are 0 to 1, minus, here with respect to y means this is y square by 2, limits are 0 to 1 into dz. So here, now I am using the values, that is upper limit minus lower limit. So 4z into 1 minus 0 minus 1 by 2 into dz. So that is only we are having here. So 4z minus 1 by 2 into dz. Now I am doing with respect to z. So 4 integral z is z square by 2. Limits are 0 to 1 minus 1 by 2 into integral dz is z. Limits are 0 to 1. So here 2 2s are 4. So 2z square minus 1 by 2 into z. So this is 1 minus 0. So 2 minus 1 by 2. Finally we got the answer 3 by 2. So triple integral over v. Del dot f dv value we got 3 by 2. So this is the way to calculate using Gauss Divergence Theorem. So now second one. Verify the Gauss Divergence Theorem. F bar equal to 4x(i) minus y square j plus yzk. So same problem they are asking verify Gauss Divergence Theorem means we have to do the two parts. We have to evaluate surface integral also and RHS part volume integral also. We can see how we can solve. So here given verify Gauss Divergence Theorem for F bar equal to 4xz into I minus y square j plus yzk over the cube bounded by x equal to 0 and x equal to 1, y equal to 0, y equal to 1 and z equal to 0 and z equal to 1. So here we are writing the given data given f bar equal to 4xz into I minus y square j plus yzk. Now first I am doing the RHS part. For the RHS part I need del dot f as like a previous problem. So I am doing here del dot f is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So what is the f1 here? F1 is 4xz, f2 is minus y square, f3 is yz. That is all we are doing here. So dou by dou x of f1 is 4xz plus dou by dou y of f2 is minus y square plus dou by dou z of f3 is yz. That is all we are doing here. With respect to x we are doing this is 4z. Here with respect to y we are doing. So here y square is minus 2y. With respect to z we are doing. So y into z is 1. So minus y. So finally del dot f value is 4z minus y. So now we are calculating the RHS part. Double integral, triple integral over V, del dot FTV, that is equal to integral 0 to 1. And how we got the limits? X equal to 0, X equal to 1, Y equal to 0, Y equal to 1, and Z equal to 0, Z equal to 1. They given in the problem. That is cube is bounded by these values. Cube is bounded by these values. Now, so we are writing here, we are having all x, y and z limits. So, integral 0 to, already we know about the dv also. What is the dv? dx, dy, dz. They given the statement of the Gauss Divergence Theorem. So, integral 0 to 1, here integral 0 to 1, here integral 0 to 1, 4z minus y. This value is 4z minus y. So, dx, dy, dz. Now we are writing x limits are 0 to 1, y limits are here x equal to 0 to 1, y equal to 0 to 1 and z equal to 0 to 1. Now we are doing first with respect to x. Here 3 values, that means 3 limits are constant, means we can do any one first. Otherwise, if you are having one variable, one constant, means first we have to do with respect to variable limits, after then finally constant limits. So here first we are doing with respect to x. So 4z integral dx is x. Here y into integral dx is x. So in the place of x we are going to replace the limits now. So 4z into 1 minus 0, y into 1 minus 0. Finally we got 4z minus y. Now we are doing with respect to y. So 4z into integral dy is y. So integral y is y square by 2. Limits are 0 to 1 into dz. So integral 0 to 1, here we are replacing 4z into 1 minus 0 minus 1 by 2 into 1 square minus 0. So finally 4z minus 1 by 2. So here integral 0 to 1, 4z minus 1 by 2 into dz. Finally we are doing with respect to z. So integral 0 to 1, 4 det dz minus integral 0 to 1, 1 by 2 dz. So 4, here integral z is z square by 2, limits are 0 to 1, minus 1 by 2 into integral dz is z 0 to 1. So finally we are substituting here 2 into z square minus 0. So here 1 square 0 to 1. First upper limit minus lower limit, minus 1 by 2 into 1 minus 0. So finally 2 minus 1 by 2, this value is 3 by 2. So now I calculated or completed del dot f into dv value I got, that is 3 by 2. So one part is completed. So here they are asking to verify the Gauss Divergence Theorem. That means LHS part also we have to prove, that is 3 by 2. Then we can verify the Gauss Divergence Theorem. So for the LHS part, we need to calculate integral over S f bar dot n bar ds. F bar dot n bar ds. That means all surfaces integral value we have to calculate. For the cube, we are having how many surfaces we can observe here. This is the 1, 2. So this is 3, 4, 5, 6. So we are having 6 surfaces. That means this integral value we have to calculate for all surfaces. So first surface S1, second surface S2, third surface S3 and S4, S5 and S6. So this one we are going to calculate now. So that's why that first surface S is equal to S1 plus S2 plus S3 plus S4 plus S5 plus S6. That means all surfaces. So then only it will become the cube. So now first we are taking the S1. S1 is the bottom we are taking. So this one is x into y. So where is the surface? This is in the plane x and y. So on x and y plane, so z is 0. That means we will get only xy. So dx dy. So along that, when you are taking the surface integral, already we know the surface integral problem. According to that, if you are having the xy plane, you will take n dot k, right? So according to that, we are taking n cap is minus k bar unit normal. So minus next one. So here f dot n bar. F dot n bar is f bar already. What is the f bar is 4x z I 4x z I minus y square j plus yzk. So now we are doing so f bar dot n bar. So f bar dot n bar we are getting here. So this is n is minus k bar. So yz into k. So finally we got minus yz and z equal to 0. Now we are doing the surface. In that one we are getting that value is 0. So f dot n on s. So here dz, this is 0. So z equal to 0 means z is 0. So on xy plane z is 0, right? So now we are evaluating that integral over 0 to 1 x limits and y limits. So we got f dot n value is 0. So dx dy. So finally this is 0. This is 0. So in the same way for the surface S2 we are calculating. So surface S2 is here. Surface S2 is here. So now here plane is xy plane only. It is also in the xy plane. So this is dx dy and here we are taking this one is positive, negative means this is the positive, right? So now this is k bar. So if it is k bar means f bar dot n value is yz. So here this is z equal to 1 plane. Z equal to 1 plane. So now if it is z equal to 1 plane, what is the integral value? Integral 0 to 1, integral 0 to 1. Z is 1. So here f dot n value z is 1 means we are getting here y into z is 1 dx dy. Dx dy. So when you are integrating this function we are getting here with respect to, so final value this is integral 0 to 1 y dx dy. So if you are integrating this one we are getting integral 0 to 1 y dy. So integral 0 to 1 into dx. That means first we will do with respect to y, after with respect to x. The same way for the S3 also. Now we are taking this is S1, S2 and S3. S3 is the left, S3, S4. So S3. So what is the S3 here? This is in the which plane? X and Z. So we will take xz. So dx dz. So here along y-axis. So what is the vector we are taking? That we will going to take here. That is j bar. Here we are taking minus j bar means here positive. Here k bar. So here minus k bar. So like that here first we are taking minus j bar. So minus j bar means that value is y square. So y square. So y equal to 0. Here y on xz plane y is 0. On xz plane y is 0. So that value becomes 0. Finally integral 0 to 1. Integral 0 to 1. This value is 0. That value is f bar dot n cap. So dx dy. So that means this value is 0. This value is 0. Now we are calculating for the surface S4. So S4. This is also in the xz plane only. Xz plane. So here this is the positive. We are taking this opposite, right? This opposite value means this is positive. So xz. So dx dz. The vector is j bar. Now y equal to 1 we are taking. Y equal to 1. So this value we got for the minus 1. So finally integral 0 to 1 integral 0 to minus 1 into dx dz. This value integral about the S4. Now we are taking S5. That means this is the S5 and this is the S6. This is the S6. So now JK completed. Now this one along I bar because this is in the YZ plane. So here I bar means here minus I bar means here I bar. So now we are taking S5. So YZ plane dy dz here minus I bar. So this value is according to the f bar we will take minus I bar means f dot I. So minus 4xz. So x is 0. Finally got 0 here. So integral 0 to 1, integral 0 to 1, 0 dy dz. This value is 0. This value is 0. Now we are taking the S6, surface 6. We are taking as a friend. That means yz plane. So dy dz. This is I bar. So f dot I is 4xz. So x equal to 1 we are taking here. That value is 4zx. So x value is 1 means this value becomes 4z. So integral 0 to 1, integral 0 to 1, 4z dy dz. Now we got the integral values of all surfaces. We are going to calculate all these values and we can sum up to get the double integral s f bar dot n ds. Now, first, double integral over s f bar dot n ds plus double integral over s to f bar dot n ds. So, integral 0 to 1, this is only we are taking from the table. So, first one is this. So, integral 0 to 1, integral 0 to 1, 0 dx dy. So, plus integral 0 to 1, integral 0 to 1 y dx dy. So, here this value is 0. This value is 0. Now, we are going to evaluate this integral. So, integral 0 to 1, integral 0 to 1 y dx dy. So, now first we are doing with respect to x. So, integral 0 to 1 y, integral dx is x. Limits are 0 to 1 into dy. So, now integral 0 to 1 y into 1 minus 0 into dy. So, integral y dy is y square by 2. Limits are 0 to 1. Finally, upper limit minus lower limit by 2. So, we got 1 by 2. This is the S1 plus S2 value is 1 by 2. S1 plus S2 value is 1 by 2. Now we are taking S3 and S4. S3 and S4. So from the table we can observe here S3 integral value and S4 surface value. So integral 0 to 1, integral 0 to 1, 0 dx dz. So this value is 0. Now we are going to calculate this value. Integral 0 to 1, integral 0 to 1, minus 1 into dx dz. So, minus 1 into integral 0 to 1. Integral dx is x. Limits are 0 to 1 into dz. So, minus 1 integral 0 to 1. 1 minus 0 dz. So, here minus 1 integral dz 0 to 1. So, finally this is minus 1. So, S3 plus S4 value is minus 1. Now we are taking S5 and S6. S5 and S6. So S5 value we got the integral like this. Integral 0 to 1. Integral 0 to 1. 0 dy dz. So that value is 0. So here integral 0 to 1. Integral 0 to 1. 4z dy dz. We are going to evaluate this integral. So integral 0 to 1. Integral 0 to 1. 4z dy dz. So first we are doing with respect to y. So integral 0 to 1, 4z into integral dy is y. Limits are 0 to 1 into dz. So, upper limit minus lower limit. So, 4z into 1 minus 0 into dz. So, finally, we got integral 0 to 1, 4z dz. 4z dz. Now, integral z. So, 4 is the constant. Integral z is z square by 2. Limits are 0 to 1. So, this value is 2 to 0. 4, so 2 into 1 square minus 0. Finally, this is 2. So, S5 plus S6. This value we got 2. This value we got 2. Now, we are going to sum up S1 plus S2, S3 plus S4 and S5 plus S6. We can observe here double integral over S f bar dot n bar ds equal to double integral over S1, S2 plus S3 plus S4 plus S5 plus S6. So, S1 plus S2 I done 1 and S3 plus S2 I got in second equation. S5 plus I6 I got in the third equation. So S1 plus S2 value is 1 by 2 and S3 plus S5 value is minus 1 and S5 plus S6 value is 2 I got. So when you are simplifying this, I got the value 1 minus 2 plus 4 by 2. So this is 5 minus 2, that is 3 by 2. So finally RHS, LHS value double integral over S f bar dot n cap ds equal to 3 by 2. 3 by 2. This is the LHS part. So already we calculated RHS part before. So that is RHS equal to triple integral over V del dot FdV is 3 by 2. So these two values are equal. That means therefore integral over S f bar dot n cap ds equal to integral over V del dot f dv. So this theorem is, hence Gauss Divergence theorem is verified. So here if they are asking to verify the Gauss Divergence theorem, we have to calculate the surface integral and volume integral, and we have to show that these two values are equal. So then we can say that Gauss Divergence theorem is verified. So for these problems, I used these references. So engineering mathematics textbook written by TKV Iyengar, and one more textbook BS Gravel. We can use one more BV Ramana also, and we can refer Bali written by Bali also, engineering mathematics textbook written by Bali also, and these are the Google links I used here. If you want to get the more information, you can go through these references. I hope you understand about the what is the Gauss Divergence theorem, what is the statement of the Gauss Divergence theorem, and how to use Gauss Divergence theorem, and how to verify the Gauss Divergence theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.